Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, I'm going to be working out some practice questions that should closely mirror what you'll see on the Arithmetic Reasoning Subtest of the Armed Services Vocational Aptitude Battery, that is the ASVAB. As a reminder, you're not allowed to use a calculator or a reference sheet on the ASVAB, so you're going to have to be able to do all these problems without those resources. In addition, I want to mention that to get the most out of this video, I strongly encourage you to pause a video after I read each question, attempt to work out the question on your own, and then resume playing the video to see if you and I came up with the same solution. In the description of this video, I'm going to put timestamps for each question. Next to the timestamp, there's going to be a topic that the question's covering, and next to the topic, there's going to be a link to a video where I discuss that topic in greater detail. So if at any point you need more help with any of these questions, just take a look in the description of this video, and there you'll find additional resources. So all those things being said, let's go ahead and get started with today's video. All right, number one says a roll of plastic electrical tape costs $2.79. If the sales tax is 5%, then what is the total cost for the tape? So in this case, we have to find what 5% of $2.79 is, and then we're going to add that to $2.79. So that looks like this. Again, we're doing $2.79 times 5%. In terms of a decimal, 5% is 0.05. So as you can see, we're multiplying a decimal by a decimal, notably 2.79 by 0.05. In order to proceed, we have to shift these decimals in both numbers such that they become whole numbers. So in 279, I'm going to shift the decimal place 2 times to the right, and in 0.05, I'm going to shift the decimal 2 times to the right. That makes 2.79 279, and 0.05 just 5. And once I do this arithmetic, I'm going to have to shift this decimal place 4 times back to the left to make up for the fact that I shifted it over here. So let's go ahead and do that. 9 times 5 is 45, so drop down your 5 and carrier 4. 7 times 5 is 35, plus 4 is 39, carrier 3. 5 times 2 is 10, plus 3 is 13. Bring your 4 decimals back in. 1, 2, 3, 4. So as we can see, 5% of 279 is 0.1395. So all we have to do is take this and add it to 279 now. So that's going to be 279 plus 0.1395. And again, if you want to, you can add zeros here and here. And make sure to line up your decimals as you do this. As a matter of fact, you can drop down your decimal in place right now. 0 plus 5 is 5. 0 plus 9 is 9. 9 plus 3 is 9, 10, 11, 12. Carrier 1. 7 plus 1 is 8, plus 1 is 9. And 2 plus nothing is 2. In this case, we look at our answer choices and we don't see this number, and that's because they round it. So in light of that, we're going to look at this place right here. This is tens place, this is hundreds place. We're going to look to the right of the box number, and if that number to the right is greater than 5 or equal to 5, we round up. As we can see, it's 9. So this becomes 293, which we can see is A. Okay? On the ASVAB, you're going to have some scenarios where you're going to solve a problem. It's not going to be exactly one of the answer choices, and you're going to have to realize that you're simply going to have to round your answer to find the right answer on the ASVAB. Okay, so that was a good example of that. All right, number 2 says Mr. Smith had enough sugar to make 3/4 of a batch of cookies. To make a whole batch, he needed 1/3 of a cup of sugar. How many cups did Mr. Smith have? So there's a few ways to solve this one. I think the easiest way is to set up a proportion. Again, we know to make a whole batch, you need 1/3 cup of sugar. So let's write that in as 1/2 of our proportion. Again, that's one batch requires 1/3 cup of sugar. And now we can just fill in what we have on the other side of this proportion. Again, we know he made 3/4 of a batch. And we want to find out how much sugar he used. So we can call that X amount of sugar. To solve this one, we just cross multiply. That is, we can do 1 times X, which is just X. And then we can do 1/3 times 3/4, which looks like this. And again, as you can see, we're multiplying fractions now, notably 1/3 and 3/4. To multiply fractions, you just multiply straight across. That is, you do 1 times 3, which is 3, and then 3 times 4, which is 12. We can reduce this fraction by factoring out a common multiple. 3 and 12 are both divisible by 3. 3 divided by 3 is 1, and 12 divided by 3 is 4. So as we can see, X, which refers to sugar, is 1/4, which means that Mr. Smith used 1/4 cup of sugar to make 3/4 of a batch of cookies. Okay? So that was that one. Number 3 says gas prices decreased this week from $4 per gallon to $3.80 per gallon. What rate of decrease does this represent? So this is a percent change problem. So we know we can solve it using this formula. Percent change equals new minus old over old times 100. Of course, the new amount is 380 in this case because it went from 4 to 380, which means the old amount is 4. So all we do is have to plug these things in to figure out what the percent change was. So again, let's go ahead and do that. The new amount, as I mentioned, is 380, and the old amount was $4. Again, this is all over 4, and we're going to multiply it by 100. This math is pretty easy to do. We have 380 minus 4, which is negative 0.20 over 4, and that's going to be times 100. Let's work this off to the side since it's, as you can see, subtraction involving a decimal and a whole number. Again, we can read this fraction as 0.20 divided by 4. Now, the key to doing long division in fractions is this. As long as the decimal's inside this division bracket, we can proceed as we normally would. If, however, the decimal's outside this division bracket in the divisor, we can't proceed as we normally would. As we can see, it's in 0.2, so that's inside the division bracket. All we have to do is bring it up right there. Now the question is, how many times does 4 go into 2? It doesn't. How many times does 4 go into 20? Again, since 4 doesn't go into 2, we can put a 0 there. And 4 goes into 20 5 times. 5 times 4 is 20. So 20 minus 20 has no remainder. So we can see that negative 0.20 divided by 4 is going to be negative 0.05. And again, that's times 100. In order to figure this out, again, we're just multiplying a decimal by a power of 10. So to do this mentally, we're just going to take its decimal and shift it to the right however many times there are in the power of 10. In 100, there are 2 zeros. So we're going to shift this decimal 2 times to the right. So we can see the percent change is going to be negative 5%. Again, this negative means there was a decrease, so we can disregard that. But that said, we see that there was, in fact, a decrease of 5%, which is B. Okay, so that was that one. All right, number 4 says, Robert, a wheat farmer in Iowa, had 12 tons of grains after this year's harvest. If he gave 25% of grains to his friend, how many pounds of grains does Robert have left? So right away, we should realize that we're being asked to find how many pounds, but we're given how much he has in terms of tons. So at some point, we're going to have to make a conversion from tons to pounds. Again, 1 ton is equal to 2,000 pounds. So let's be mindful of that as we work on this problem. Before we make any conversions, though, we have to subtract out this 25% that he gave to his friend. So in other words, we're going to do 12 times 0.25. This number is the amount he gave to his friend, so we'll subtract that from 12 when we're done. You could multiply 12 by 1/4 if you wanted to, if you like fractions better than decimals. Either way is fine. But let's work on this. Again, we're doing 12 times 0.25. In order to do this, we're going to have to make this decimal a whole number. And we're going to shift its decimal more specifically 2 times to the right. So this becomes 12 times 25, albeit with 2 decimals to shift back into the left at the end. Let's work this out, and then we'll make that conversion from tons to pounds. 5 times 2 is 10, carrier 1. 1 times 5 is 5 plus 1 is 6. Drop down a 0 before you start multiplication with this number. 2 times 2 is 4. 1 times 2 is 2. Let's add. 0 plus 0 is 0. 4 plus 6 is 10, carrier 1. 1 plus 2 is 3. Bring your 2 decimals back in. 1, 2. So this represents 25% of 12, which is 3 tons. In other words, he gave 3 tons away of his grains to his friend. 12 minus 3 is 9. So he kept 9 tons. Okay? So Robert has 9 tons after giving 3 tons away, which is 25% to his friend. Now we have to figure out what this 9 tons is in terms of pounds, and that's pretty easy. Again, 1 ton is 2,000 pounds, so 9 tons is going to be 2,000 times 9. 0 times 9 is 0. 0 times 9 is 0. 0 times 9 is 0. 9 times 2 is 18. So we can see that is 18,000 pounds, which is D. Okay? All right, number 5 says, on a map, 5 inches represents 100 miles. How many inches would there be between 2 cities that are 2,500 miles apart? So again, whenever you're dealing with maps and scales, you want to set up a proportion to solve them. Again, I'm going to set half of this proportion to be what I'm given already. So 5 inches represents 100 miles. So let's go ahead and write that on the left-hand side of our proportion. Again, that's 5 inches corresponds, and that should be an S there, to 100 miles. Now let's fill in the right-hand side of our proportion. Again, we're told that the distance between the 2 cities is 2,500 miles. So again, we have miles in the denominator, so let's keep it in the denominator. This is 2,500 miles. And we want to figure out what that is in terms of inches on a map. So that's X inches. To figure this one out, we're just going to cross multiply. I like to cross multiply with the X first, so it's on the left-hand side. So I'm going to do X times 100, which is 100X, equals 5 times 2,500, which looks like this. 5 times 2,500. Okay. Again, I'm not going to skip any steps as I work this out. I'm sure many of you could, but again, in light of the fact I don't know who's watching this video, I'm going to work this out step by step. So again, we have on this right-hand side of the equation 2,500 times 5. So let's figure out what that is. 5 times 0 is 0. 5 times 0 is 0. 5 times 5 is 25, so drop down your 5 and carry your 2. 5 times 2 is 10, plus 2 is 12. So we can see that 5 times 2,500 is 12,500. Of course, this equals 100x. To solve for x now, we're going to divide both sides by 100. This is going to cross out, leaving you with just x over here. Let's cross out these corresponding zeros. So this becomes 125 divided by 1. Anything divided by 1 is itself. So this is 125 inches. Again, x, as you can see, corresponded with inches in our proportion. So we know our units in terms of our answer is going to be inches as well. And that is C in this case. Okay, so far this practice test has been pretty easy. Again, the ASVAB is a computer adaptive test. So in the beginning, regardless of how good you are at math, you're going to get some very simple problems. As you get those questions correct, the questions are going to get more difficult. And that's going to be the case for this practice test as well. All right, number 6 says the temperature in Monkey's Eyebrow, Kentucky during a week was 35, 36, 34, 38, 40, 39, and 44 degrees centigrade. What was the average daily temperature of the town for the week? So in this case, we want to figure out what the average is. Again, I like to think of average like this. Average equals the sum of the numbers divided by how many numbers there were. So let's go ahead and fill this in accordingly. Again, I could give you the statistical definition of average, but that formula is too advanced for the ASVAB. You really don't need it. Again, you're just summing the numbers and dividing the sum of those numbers by how many numbers there are. So we're going to sum up all these numbers. As you can see, we have 35, 36, 34, 38, 40, 39, and 44. Of course, the problem said this was for a week, but that said, let's count up how many there are. There's 1, 2, 3, 4, 5, 6, 7. Okay, so they weren't lying. So this is going to be over 7. At this point, we want to take our time and add up all these numbers in the numerator. And I recommend doing that vertically so you don't make any mistakes. Again, regardless of how good you are at math, anyone can make a mistake doing this arithmetic. So let's do it vertically. We have 35, 36, 34, 38, 40, 39, and 44. Let's go ahead and add this up. And I'm going to do this in a quick way. I'm going to do 6 plus 4 is 10. 9 plus 8 is 17. And then 5 plus 4 is 9. So this is 19 plus 17, which I'm going to do off to the side so I don't make any mistakes here. 9 plus 7 is 6, carrier 1, or 16, carrier 1. 1 plus 1 plus 1 is 3. So we're going to drop down a 6 and carry a 3. All right, let's go ahead and add up this left column now. And again, take your time so you don't make any mistakes. We have 3 plus 3, which is 6, plus 3, which is 9, plus 3, which is 12, plus 3, which is 15, plus 3, which is 18. So that's 18 in terms of threes. Then we have 4 plus 4, which is 8. So this is 18 plus 8. 8 plus 8 is 16, carrier 1. 1 plus 1 is 2. So this is 266. So let's keep working this out. This becomes average equals 266 over 7. Again, we can regard fractions as long division. So another way to read this is 260, and my pen is acting up. That's not a good sign. 266 divided by 7. Okay, let's work this out. 7 doesn't go into 2, so we're asking ourselves now, how many times does 7 go into 26? 7 times 4 is 28, whereas 7 times 3 is 21, so this is going to be times 3. 7 times 3 is 21. 26 minus 21 is 5. Drop down this 6, of course. 7 goes into 56 8 times. 7 times 8 is 56. So we can see there's no remainder. Therefore, we know the average was 38 degrees centigrade, which is B, of course. Okay, so that was that one. All right, number 7 says, from a deck of cards that's been shuffled very well, you draw a card, put it back, and draw a new one. What is your probability of drawing 2 aces? So in a deck of cards, there are 4 aces, okay? And in addition, there are 52 cards in a standard deck of playing cards. So we have to know those things in order to approach this problem. Again, this is a very basic probability question, and it's one of this nature. Probability of drawing an ace and then drawing another ace with replacement. So to find it, we're going to do probability of drawing an ace the first time times the probability of drawing an ace the second time. And now we can use our information about a deck of cards. Notably, there's 52 cards in a deck and 4 aces in a deck. So that means on this first draw, you have 4 chances out of 52 of picking an ace. And then on your second draw, since you put that card back, you have, again, 4 out of 52 odds of drawing an ace. To make this math a little bit easier, let's go ahead and simplify 4 and 52 since they're both divisible by 4. And I'm going to do it for both of these just to make it a little bit easier. 4 divided by 4 is 1. 52 divided by 4 is 13. So this becomes 1 over 13 times 1 over 13. I'm more comfortable doing this now. And as you can see, we're multiplying a pair of fractions. In order to do that, you multiply across. That is, you do 1 times 1 and 13 times 13. 1 times 1 is 1. 13 times 13 is 169. So to answer this question, your odds of drawing an ace 2 times in a row are 1 out of 169. Okay, that's about 0.5%. All right, number 8 says the half-life of uranium-238 is 4.5 times 10 to the 9 years. The half-life of uranium-234 is 2.5 times 10 to the 5 years. How many times greater is the half-life of uranium-238 than that of uranium-234? So as you can see, we're dealing with scientific notation, and more specifically, we're trying to figure out how much longer the half-life of uranium-238 is than uranium-234. So we're going to do this. We're going to do 4.5 times 10 to the 9th and divide it by, and again, this is uranium-238 or U-238. This is going to be uranium-234. We're going to divide that by 2.5 times 10 to the 5th. All right, so we can, this isn't part of the problem. I've just put that there so you know which one's which. But now we're doing 4.5 times 10 to the 9th divided by 2.5 times 10 to the 5th. That is, we're trying to divide two numbers that are written in terms of scientific notation. In order to do this, you break them apart. That is, you do 4.5 divided by 2.5, and then you multiply that by 10 to the 9th divided by 10 to the 5th. As it turns out, this is pretty simple and straightforward to do. Again, in order to solve this on the right, that is 10 to the 9th divided by 10 to the 5th, you can make use of one of the laws of exponents, notably the quotient law, which says if you have a to the m and you divide it by a to the n, you can simply subtract their exponents. So this would become a to the m minus n. As you can see, that's exactly what we have here. Again, in place of a, we just have 10. So to figure out this over here, it's just going to be 10, and we're going to subtract our exponents, 9 minus 5. And we've done this side. Okay, this is simple arithmetic, 4.5 divided by 2.5. So let's go ahead and work that off to the side as well. That's 4.5 divided by 2.5. As I mentioned previously in this video, in order to do division with decimals, you have to ensure that there's no decimal outside the division bracket in what's called the divisor. As we can see, the divisor is 2.5, which is a decimal. So we're going to have to shift this decimal in 2.5 such that it becomes a whole number. So I'm going to shift it one time to the right to make 2.5 25. And then I'm going to do that a corresponding number of times to this number inside the division bracket. So that's going to become 45. So in reality, I'm working out this problem. And now I'm asking myself, how many times does 25 go into 45 without going over? That's going to be one time. 1 times 25 is 25. So let's subtract that out. 45 minus 25 is just going to be 20. Now we're asking ourselves, how many times does 25 go into 20? It doesn't. We have to add another 0. And then by adding that 0, we have to bring up a decimal. 25 goes into 208 times. 25 times 8 is 200. So we can see there's no remainder. So we can see 4.5 divided by 2.5 is 1.8. So now this becomes 1.8 times 10 to the 9 minus 5 is 10 to the 4th. We can expand this out to figure out what this number really is. Again, we have 1.8 here, and we're multiplying it by 10 to the 4th. Again, this says take your decimal and shift it 4 times to the right. So our decimal's right here in 1.8, so we're going to shift it 1, 2, 3, 4, and add in zeros accordingly. 1, 2, 3. So we can see that 1.8 times 10 to the 4th is 18,000, which is D. In other words, uranium-238's half-life is 18,000 times that of uranium-234. Okay, some simple math there. All right, number 9 says an airplane flies at a constant rate of 800 miles per hour. How far can it travel in 15 minutes? Okay, so we should recognize that we have all the elements of distance, rate, and time. That is, we have d equals r times t, where d stands for distance, r stands for rate, and t stands for time. Let's identify what we have so we can plug things in and solve. Okay, we know what our rate is. That's 800 miles per hour. We know what our time is. That's 15 minutes. And we want to figure out how far it can travel. So that's going to be our distance. So we're going to leave distance as d. We're going to plug in 800 as our rate. That said, if you know how to use this formula, you should be mindful of the fact that time is always in terms of hours. So we can't just plug 15 into this formula because that would say 800 times 15 hours. Instead, we have to write 15 minutes in terms of hours. So that looks like this. We're just going to take 15 and divide it by 60. And of course, we should realize that if we divide 15 and 60 by 15, this reduces to 1/4. Again, 15 minutes is a quarter of an hour. Okay, so this becomes 8 800 times 1/4. Let's go ahead and work this out. Again, we're multiplying a whole number by a fraction. One way you can solve this is by rewriting the whole number as a fraction as well. So I can rewrite 800 as a fraction by placing it over 1, since anything divided by 1 is itself. So this becomes 800 over 1 times 1 over 4. And now we're just multiplying two fractions, which means we can simply multiply straight across. So this becomes 800 over 4. Of course, we know 8 divided by 4 is 2, and just tack on these two zeros. So in other words, in 15 minutes, a plane going at 800 miles per hour can travel 200 miles. Okay, again, most people get tripped up right here. Time's always in terms of hours. In the distance formula, you have to convert it to a proportion in terms of hours to solve this one correctly. That said, it wasn't too difficult. All right, number 10 says, it takes 3 hours to wash every window on a building. If the building has 30 windows, how many seconds does it take to wash each window? All right, so right away we should realize that we have another conversion problem, since we have to go from hours to seconds. Again, as far as converting time goes, you have hours, minutes, and seconds. In order to go from hours to minutes, you multiply by 60. And to go from minutes to seconds, you multiply by 60 again. That said, we have to figure out when's going to be the best time to make these conversions. I think right off the bat, it's going to be easiest to convert hours to minutes. So I'm going to take 3 hours to start, and I'm going to convert that to minutes by multiplying it by 60. Okay? 0 times 3 is 0. 6 times 3 is 18. So we can see that 3 hours is the same as 180 minutes. So let's figure out how long it takes in terms of minutes to wash 30 windows. That's going to be 180 divided by 30. Again, this will tell us how long it takes per minute to wash each window. We can cross out these corresponding zeros. So this becomes 18 over 3. 18 over 3 is going to be 6. Again, 6 times 3 is 18, so 18 divided by 3 is 6. In other words, it takes 6 minutes to wash each window. So now we have to make our final conversion, and we're going to convert minutes to seconds. So we're going to take this 6 and multiply it by 60. So this is going to be 60 times 6. 0 times 6 is 0. 6 times 6 is 36. So 6 minutes in terms of seconds is 360 seconds. And I'm starting to hit the side of the program there. So this becomes 360 seconds, which is C. Again, we had to go from hours to minutes and then minutes to seconds. And we did that by multiplying by 60. Okay, pretty simple problem otherwise. All right, number 11 says Sam wants to earn an 80% in chemistry class, and he has one quiz left to take. On the first 5 quizzes, he received a 75%, 90%, 80%, 60%, and 100%. What must he score on his 6th quiz to get the 80% he wants? So this is a variation of an average problem. So again, average is simply the sum of the numbers divided by how many numbers there are. That said, we're given what average he wants. He wants an 80%. So this is going to be our average. And we're only given 5 of his 6 quiz scores. So let's plug this in and see what it looks like. Again, we know he wants to have an average of 80. So we're going to plug in 80 for average. We know his 5 quiz grades were 75, 90, 80, 60, and 100. We want to know what his sixth quiz grade must be, so we can represent that as X. And similarly, we should realize that we're finding the sum of 6 quizzes now, including the unknown quiz grade, which I represented as X. So that's 1, 2, 3, 4, 5, 6. So I'm going to put 6 in the denominator down there. Now we're just solving for X. Again, as the first thing, I'm going to multiply both sides by 6 just to get rid of it from the denominator. This crosses out. Doesn't cross out the X, it just crosses out the 6's. And 6 times 8 is 480. So this becomes 75 plus 90 plus 80 plus 60 plus 100 plus X equals 480. Again, we're trying to solve for X here. So as our next step, let's go ahead and sum up all these values there. And again, so as not to make any mistakes, let's do it vertically. We have 75, 90, 80, 60, and 100. This one should be pretty easy since the scores are pretty even. 5 plus all these zeros is just 5. This one's a little more challenging. Let's do 7 plus 6 is 13. 9 plus 8 is 17. Let's do 17 plus 13. 7 plus 3 is 10. Carry a 1. 1 plus 1 plus 1 is 30. So this becomes 0 and carry a 3. 3 plus 1 is 4. So we can see this is 405 plus X equals 480. Now to solve for X, we're just going to subtract 405 from both sides. This will cross out here, leaving you with just X equals 480 minus 405. And so as not to make any mistakes, let's work that out. And that's 480 minus 405. 0 minus 5 we can't do, so we have to borrow from the number to the left. This becomes 7. This becomes 10. 10 minus 5 is 5. 7 minus nothing is 7. 4 minus 4 is 0. So we can see that X in this case is 75. That X represents the grade that he must get on his 6th quiz in order to have an 80 average in the class. So we can see that the answer to this one is B, 75%. All right, number 12 says a store marks up merchandise 40% for profit. If an item costs the store $12, what is its selling price? So in this case, I'm going to find out what 40% of 12 is, and then just add that to 12. Okay, so this is going to be pretty straightforward. Again, we want to find 40% of 12, so that's going to be 12 times 0.4. 0.4 is the decimal form of 40%. Let's work this out now. Again, we're doing multiplication involving a whole number and a decimal. In order to proceed, we have to shift this decimal one time to the right to make 0.4 just 4. So in reality, we're working out 12 times 4, albeit with one decimal to shift back into the left at the end. 4 times 2 is 8. 1 times 4 is 4. Shift our one decimal back in. So we can see that 40% of 12 is 4.8. To find the total markup, let's take 12 and add 4.8 to it. 0 plus 0 is 0. 8 plus 0 is 8. Drop down your decimal in place. 2 plus 4 is 6. And 1 plus nothing is 1. So we can see that the sale price, which includes the 40% markup on the $12, is $16.80. Okay? Number 13 says the radius of a circular playground is 60 feet. A fencing costs $5 per foot. How much will it cost to enclose it with a fence? So for this problem, I'm going to make a little diagram. Again, this is a circular playground that we want to enclose with a fence. And we're told its radius is 60 feet. And again, radius is from the center point of a circle to the edge of a circle. For this one, we're going to have to figure out what the circumference of this circle is, because again, we want to put fencing all along the edge of this circle, which is its circumference. So let's go ahead and do that. Again, circumference is found by the formula 2 pi r. And since this is the ASVAB and we're not allowed to use a calculator, we're always going to let pi be 3.14. We know what the radius is. Radius is 60 feet. So all we do is have to plug that into this formula. Once we figure out what the circumference of this circle is, we can multiply it by the cost per foot, and we'll be done. So this is going to be circumference equals 2 pi, and then the radius is 60. Let's simplify this a little bit before we move on. I'm going to do 60 times 2, which is 120. So this is 120 pi. Now I have to do 120 times 3.14. So let's go ahead and do that right here. Again, this is 120 times 3.14. As you can see, we're multiplying a whole number by a decimal. In order to proceed, I'm going to shift this decimal 2 times to the right to make 3.14 314. And of course, we're multiplying that by 120. So let's work this out. 4 times 0 is 0. 1 times 0 is 0. 3 times 0 is 0. Before we start multiplication with this 2, we have to drop down a 0 placeholder. 4 times 2 is 8. 1 times 2 is 2. 3 times 2 is 6. All right, before we start multiplication with this 1, we have to drop 2 0 placeholders in now. 1 times 4 is 4. 1 times 1 is 1. And 3 times 1 is 3. Let's add all this up. 0 plus 0 plus 0 is 0. 0 plus 8 plus 0 is 8. 2 plus 4 is 6. 6 plus 1 is 7. And 3 plus nothing is 3. Again, we have those 2 decimals that we have to bring back in. 1, 2. So we can see that the circumference of this playground is 376.8 feet. Again, the cost is $5 per foot. So we're going to take 376.8 and multiply it by 5. Again, we're multiplying a decimal by a whole number. In order to proceed, we're going to have to shift this decimal in 376.8 1 time to the right to make 376.8, just 3,076.8 times 5. And again, once we're done doing this arithmetic, we're going to shift that decimal into the left. 5 times 8 is 40, so we drop down a 0, carry a 4. 5 times 6 is 30, plus 4 is 34. Carry your 3. 7 times 5 is 35. 36, 37, 38. Carry your 3. 5 times 3 is 15, 16, 17, 18. Bring our 1 decimal back in. So we can see that the total cost to enclose this playground with a fence is $18.84, which is A right there. Okay, a lot of tedious math, but nothing too difficult. All right, so number 14 says a 10-foot ladder is leaning against the side of a building and is positioned such that the base of the ladder is 6 feet from the base of the building. How far above the ground is the point where the ladder touches the building? This is a pretty simple problem, but that said, it's going to be helpful to make a little diagram. And this is our building right here, and we know we have a 10-foot ladder leaning against it. And in addition, we also know that from the base of the building to the base of the ladder is 6 feet. According to the problem, we want to know how high it is from the base of the building to this point where this ladder touches the building. We should recognize that we have a right triangle with this ladder leaning against this building. And in light of that, we can use the Pythagorean theorem to solve this one. Again, the Pythagorean theorem is a squared plus b squared equals c squared, where a and b refer to the legs of the right triangle, and c refers to the hypotenuse. Of course, the hypotenuse is easy to identify because it's always directly across from the right angle. So 10 is the hypotenuse in this case. The one useful thing about the Pythagorean theorem is this. If you're given two pieces of the Pythagorean theorem, you can find the third piece pretty easily. And in this case, that's exactly what we have. We have the hypotenuse and one of the legs, and we want to find out what this distance from the base of the building to the point where the ladder touches it, which is one of the legs of this right triangle. I'm going to call this one A, which means this one's B, and as we know, 10 is C since it's the hypotenuse. Again, we're going to leave A squared as is since we're trying to solve for it. That said, we know B is 6, so let's plug in 6 in place of B. Again, this is 6 squared, and C is 10, so this is 10 squared. Let's keep working this out. Again, A squared plus 6 squared is 36, and 10 squared is 100. As you can see, we're solving for a squared now, so we're going to subtract both sides by 36. This is going to cross out, leaving you a squared over here. 100 minus 36 is 64, and you can work that off to the side if you wanted to. But now to get a by itself, we're going to take the square root of both sides. This is going to cross out the square, leaving us with just a. Square root of 64 is 8. So the answer to this one is the height from the base of the building to the point where the ladder touches the building is 8 feet, and we found that using the Pythagorean theorem. All right, number 15 says a boat can travel 16 miles up a river and against its current in 2 hours. The same boat can travel 36 miles downstream in 3 hours because of the river's current. What is the speed of the boat in still water? So for this problem, it's going to be helpful to make a little diagram so we can try to see what's going on. Again, that's one stream. We'll make this the other stream. I'm going to call this one U for upstream and D for downstream. We know it goes 16 miles upstream, and it takes 2 hours. And similarly, we know the boat takes 3 hours to go 36 miles downstream. All right, so let's put our boat in the water, so to speak. And let's try to see what this current's doing. Again, this boat is going upstream, so it's going this direction, whereas the current is pushing against it. So it's going to slow down its rate of speed. Let me point out that in order to solve this one, you're going to have to make use of the distance formula. That is, distance equals rate times time. But that said, we're not given any information about rate in this problem. So we're going to have to kind of come up with our own rate. In this case, we can see that the current is acting upon the rate of this boat. More specifically, it's slowing it down. So I'm going to call the rate of this boat going upstream R minus C. Again, it's trying to push through the current, which is slowing it down. And in this case, the boat's going downstream. The current's also going downstream. So this current is speeding this boat up. So I'm going to call the rate of this boat R plus C. Okay, so using the distance formula and all this information, we can figure out the rate of the speed of the boat in still water. But that said, we're going to have to organize this into a little chart. And instead of being distance equals rate times time, I'm going to write this as rate times time equals distance. So I can fit that into my chart. Again, this is going to be rate here. This is going to be time here. And this is going to be distance here. And again, we'll do this as upstream and this as downstream. For upstream, we said the rate was being slowed down by the current, so we're going to call that R minus C. And the problem told us it took 2 hours to go 16 miles upstream. Again, downstream, the current is pushing the boat, so it's speeding up its rate, so that's going to be R plus C. Again, we're told it took 3 hours to go 36 miles. Okay? So let's go ahead and multiply this out. Again, this is R minus C times 2 equals 16. And then this one is R plus C times 3 equals 16. Again, I just did R times T equals D, which is the distance formula. All right, so as you can see, we almost have a system of equations we can use to figure out what R is. That said, we have 2 times R minus C and 3 times R plus C. We can get rid of this 2 by dividing both sides by 2, and we can get rid of this 3 by dividing both sides by 3. 2 divided by 2 is, and this should be 36, not 16, so let me fix that real quick. Sorry about that. This is 36, not 16. This crosses out here, leaving you with just R minus C equals 16 divided by 2, which is 8. The 3's cross out here, leaving you R plus C, and 36 divided by 3 is 3 goes into 3 one time, 3 goes into 6 2 times. Okay, so now we have a system of equations we can use to solve for either R or C as we want. Again, R represents the rate of the boat and still water. So we're going to solve for R. Again, to solve a system of equations, you have to pick a method, either elimination or substitution. In this case, we can eliminate the variable C by simply adding these two equations together. So I'm just going to add R minus C equals 8 to R plus C equals 12. R plus R is 2R. C, negative C plus C is nothing. 8 plus 12 is 20. Divide both sides by 2 to get R by itself. This crosses out, leaving you with R equals 20 divided by 2, or 10. So in other words, the rate of speed of this boat in still water is 10 miles per hour, which is C. If you're doing really well on the ASVAB, you are going to see a distance equals rate times time problem, where you're going to have to account for either the speed of a current in a boat or the jet stream in an airplane, and you're going to have to set up a system of equations in order to solve these problems. So again, if you're going to score somewhere between 90 and 99, you should anticipate at least one of these problems. All right, so let's take a look at the final question in this video. It says, what is the sum of the integers from 1 to 150? In other words, we want to take the integers between 1 to 150 and add them up. That looks like this. 1 plus 2 plus 3 plus 4 plus 5, dot, 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 all the way to 150. This dot, dot, dot is an ellipsis. It means there are numbers between 5 and 150. Let me get rid of that junk right there real quick. So in order to figure this one out, we have to realize that we're trying to find the sum, essentially, of an arithmetic sequence. Again, an arithmetic sequence is one in which it takes a constant to get you from one term to the next term in the sequence. As we can see, to go from 1 to 2, we add 1. To go from 2 to 3, we add 1. To go from 3 to 4, we add 1. And so on and so forth for this entire sequence. And since this is an arithmetic sequence, we can solve it using this formula. S to the n equals n a1 plus an all over 2, where n refers to the last term in the sequence, and a1 is the first term in the sequence. So Again, 1 is the first term of the sequence, so that's going to be a 1. That means 2 is a 2. That means 3 is a 3. That means 4 is a 4, which means 150, which is the last term of the sequence, is going to be a to the 150. So again, a to the n is a to the 150. Again, we can see n is 150. So let's plug those things into this formula and solve. Again, this is s to the 150. We're trying to sum all the 150 terms in this arithmetic sequence. N is 150. First term is 1. Last term is 150. Of course, this is all divided by 2. Let's make this a little bit easier to solve since I'm running out of space here. Let's divide 150 and 2 both by 2. 2 divided by 2 is 1. 150 divided by 2 is 75. So this becomes s to the 150 equals 75 times 1 plus 150, which is 151. And let's work that off to the side. Again, that's 151 times 75. 1 times 5 is 5. 5 times 5 is 25. Carrier 2. 1 times 5 is 5. Plus 2 is 7. Add a 0 before we start multiplication with the 7. 7 times 1 is 7. 5 times 3 is 35. Carrier 3. And then 7 times 1 is 7. Plus 3 is 10. Let's add this up. 5 plus 0 is 5. 7 plus 5, 7, 8, 9, 10, 11, 12. Carrier 1. 7 plus 5 is 12, plus 1 is 13. Carrier 1. 1 plus 0 is 1, and 1 plus nothing is 1. So we can see the sum of the 150 terms in this arithmetic sequence is 11,325, which we can see is in fact D. Okay, so that's it for today's video. I hope you found it helpful. As it stands, I've covered pretty much all the topics on the arithmetic reasoning as well as the mathematics knowledge subtest. And in light of that, I'm just going to start uploading practice tests like this one almost every other day for the next month. So if you like the content I'm creating, consider subscribing to my channel. In addition, you're more than welcome to leave feedback in the comment section below. But on that note, I'm going to go ahead and cut you loose. Konnichiwa.